Sum and products of roots. Now, roots are just zeros or values that solve a quadratic equation. So the question is, if alpha and beta are roots of a quadratic equation, then what is the relationship? Okay, so if we make the coefficient of x squared 1, that is x squared plus b over ax plus c over a is equal to 0. Now, if alpha and beta are roots of a quadratic equation, we could write alpha minus x, beta minus x is equal to 0. Let us expand this. If we expand, we have, so this becomes x squared minus, I will factor out x inside, I'll remain with alpha plus beta, x plus alpha beta is equal to 0. Now let us compare this equation and this equation term by term. So the coefficient of x squared is just 1. The coefficient of x in this first equation is b over a, and this other equation is negative alpha plus beta. So therefore, we know that alpha plus beta is equal to negative b over a. All right. Now, if we look at the last term, we have alpha beta is equal to c over a. Okay. Now, the only secret that you need to know is that if you have been given any question, your task is to find alpha beta. Even if it is alpha squared plus beta squared, in everything, make sure you express your roots as alpha plus beta and alpha beta. Quick question, if I ask you to find the expression for alpha squared plus beta squared, what would you do? So we know that alpha plus beta squared is just the same as alpha squared plus 2 alpha beta plus beta squared. Okay, so we can, this is just the same as alpha squared plus beta squared is equal to, so this guy goes the other side. This is alpha plus beta squared minus 2 alpha beta. Okay, so you can play around with these terms. Now, there are times when we are asked to find the quadratic equation given roots. In this example, we are told that alpha and beta are roots of the quadratic equation given by that. Now find the quadratic equation whose roots are alpha squared and beta squared. Okay. Now we know that if these given terms are roots of a quadratic equation, then this equation is satisfied. Okay, alpha squared minus x, beta squared minus x is equal to 0. If I expand this, I will get alpha squared beta squared minus alpha squared x minus beta squared x plus x squared is equal to 0. X squared minus, in brackets, I'll write alpha squared plus beta squared, then x. So what I have done, I have factored out the negative, remained with alpha squared plus beta squared, then x is factored out here. Okay, plus, so I will write alpha beta squared is equal to 0. All right. Now the question is, what is alpha squared? The question is, what is alpha squared, beta squared, and what is alpha beta? So we know that alpha beta is given by c over a. Then what is c? C is negative 2 over 4, which is equal to negative 1 over 2. Now, what is alpha squared plus beta squared? In the previous example, we showed that this is just the same as alpha plus beta squared minus 2 alpha beta. So where alpha plus beta is equal to, so alpha plus beta, we said it is negative b over a. Okay. What is b? So b is 3, so negative 3 over a is 4. Okay, so meaning that this becomes, this is negative 3 over 4 squared minus 2. What is alpha beta? Alpha beta is 1 over 2. Okay, so this is 9 over 16 plus 1. Okay, if you simplify this, you get 25 over 16. All right, so let us come back to our equation. So how does this equation becomes? Okay, so after we expanded this equation, we got this expression. So how does that becomes? This becomes x squared minus, so where there is alpha squared plus beta squared, we put 25 over 16. So 25 over 16x. Then plus alpha plus beta squared. So alpha plus alpha beta is 1 over 2 negative, then squared is equal to 0. Okay, that's it. If you want, you can expand it further. So this is x squared minus 25 over 16 x plus 1 over 4 is equal to 0. You can multiply throughout by 16. So that is the equation whose roots are alpha squared and beta squared. In this flavor of the question, we have been given that alpha and beta are roots of this equation, and we want to find the quadratic equation whose roots are 1 over alpha beta and 1 over alpha plus beta. So the first task, remember, is to find alpha beta, which is equal to c over a. Now, c is 2 and a is 2, which is equal to 1. So therefore, 1 over alpha beta is equal to 1 divided by 1, which is equal to 1. Next, we want alpha plus beta, okay, which is negative b over a. And this is negative 3 over 2. Okay, negative 3 over 2, which is a. And this is equal to 3 over 2. Now we are looking for 1 over alpha plus beta in the given question, which is just 1 divided by 2 over, 3 over 2, and this is just 2 over 3. Okay, so meaning that our question now narrows down to finding the quadratic equation whose roots are 1 and 2 over 3. Okay, so if 1 and 2 over 3 are the roots of a quadratic equation, then we must have x minus 1 multiplied by x minus 2 over 3 equal to 0. And this is the equation that we are looking for. If you want, you can end it here, or you can expand further. So, and if you do your math very well, this simplifies to x squared minus 5x plus 2 equal to 0. And we are done.